Chapter 8, Organization for Management or Manufacturing.
Good day, ma'am. I am Jeneriel Cagas, a Bshm 2B. For today's presentation, I will be present at Chapter 8, Organization for Production or Manufacturing.
Production or manufacturing, as it is more commonly called, is concerned with making of things, the creation of form utility. Etymologically, the word manufacturing means making by hand.
However, very few articles are now made solely by hands. Even the simplest type of manufacturing necessitates some tools. There are hand tools and machine tools. In addition to tools, various types of equipment are often necessary, depending on the nature of the manufacturing process.
The basic function of manufacturing is to change raw materials or secondary materials into a more useful form or state. It may involve a changing of the nature of the material or a changing or its form or both.
Together with selling, manufacturing constitutes one of the two basic functions in business. Finance is, of course, essential to both manufacturing and selling.
In the Philippines, agriculture is still the biggest sector in the economy's production pattern. It contributed 34% of total production in 1963.
Manufacturing, however, registers progressive increases.
From 11.9% of total production in 1953, it jumped to 18.5% in 1963. Manufacturing output rose from 834 pesos million in 1953 to 237 pesos million in 1963, or an increase of 223.4%. The manufacturing division of a company is usually its largest division and employs the biggest number of people. The office, personnel department, finance department, and the facilitating departments may be dominated by the manufacturing division.
In addition to the actual manufacturing unit, a factory office, a small personal staff, production control, the plant engineer, the chef inspector, the product engineer, purchasing, receiving, shipping, material or stores, traffic, and cost.
Types of production processes. The methods by which the materials of industry are produced or manufactured into the things that industry or consumers want are known as production processes. According to one classification, production processes are extractive, analytic, synthetic, and fabricating. Number 1 is extractive process. In some industries, the basic production process is one of extracting substances from the earth or the sea, known as the extractive process.
Examples of this process are mining of coal, iron, ore, lead, gold, and silver.
Number 2, analytic process. The analytic process is one in which a basic substance is broken down into a number of other materials, which may or may not bear any resemblance to the parent substance. Number 3, synthetic process. In order to turn energy and raw material inputs into desired products with the aim of optimizing a specific target function, units are assembled and connected into a process network through the process of process synthesis. Number 4, fabricating process. The term fabricating process, although used principally in the structural steel business, refers to a process that is rather widespread in industry wherein a material has its form changed to some extent by being machined, woven, cut up, pressed, finished, or treated in some other manner.
Examples of the fabricating process are to be found in the manufacture of clothing, shoes, certain types of furniture, nuts, and bolts.
Continuous and intermittent processes. A second classification of production processes includes 1. Continuous process is a procedure where the final product is produced in a continuous stream rather than in batches. Once created, the paperboard product can be continuously collected on a roll and transferred or additional processing. Number 2, intermittent process are the processes that begin at one unspecified time and terminate at a different unspecified time. The use of intermittent processes in intermittent production systems allows for the creation of goods only when they are needed or ordered by the client. Increasing production. 4 processes in production have been used to good advantage in marketing, transportation, office management, and other business functions.
However, where they find greatest application and more mainly responsible for the progress of industrialization in advanced countries.
These processes are specialization, standardization, simplification, and mechanization. Specialization involves becoming the leader or expert in a particular field, activity, or production process, like a South American company harvesting bananas. Simplification refers to the reduction in the number of types, sizes, forests, designs, colors, and other characteristics of a product. Standardization refers to the setting up of standards or norms as to size, quality, form, measure, weight, or other similar feature. Mechanization refers to the development of machines to much of the manufacturing process as possible. Manual markers are supplanted by machine skills. A method introduced in 1968 is, like some other managerial pair, a planning controlling technique. The basic analytic technique of PERT is a network consisting of a pictorial distical level his necessary work. A network path is a series of related events and activities from the beginning to the end of the network. We are interested in the network that requires the longest time because this path time controls the project. That is, any delay along this network path will delay completion of the entire project. There are different formats for calculating pertinent data work. Commonly, an average value is determined for the estimated time. Subsequently, the earliest expected achievement of the activity from the entire network viewport is calculated. This value is the sum of the expected time along the longest path from the start of the network to the event question. Finally, the latest allowable time is determined. PERT is advantageous for non-repetitive, non-routine. It is being used in research and development projects, doing new product developments, the preparation of B-runs and proposals, periodic maintenance shutdowns, pilot stations, and the construction of buildings, bridges, and power. PERT helps. A. Focus attention on potential problems in a project. B. Reasonably predict the attainment of project objectives. C. Evaluate progress toward this attainment. And D. Indicate feasible adjustment in related anti-prove overall project accomplishments. Factors involved in manufacturing. The managerial article involves the following factors: design, processing. Design. The design may be standard, static, and unchanging, as in some articles of staple merchandise. Requirement of design. The design of an article must meet 4 requirements, namely consumer acceptance, utility, economic processing, and proper kind of material to be used. 1. Consumer acceptance. Combination of the perceived variables: visual attractiveness, perceived usefulness, perceived ease of use, and perceived risk of a product or service. 2. Utility. A phrase used to assess the value or quality of a thing or service. Utility is more exactly the overall satisfaction or benefit obtained from using a good or service. It is a common assumption in economic theories of rational choice that customers will attempt to maximize their utility. Economic processing. The processes, procedures, and actions that are involved in the creation and marketing of goods and services. This covers the removal of natural resources and raw materials. As a general placeholder for all economic processes, this framework component. And number 4, kind of material to be used. The fourth requirement of design is that it must suit the material of which the article is to be made.
As an example, we have the case of copper, which is more ductile than any other common metal. Thus, it commands universal use in electrical wiring. Some aluminum wiring, on the other hand, has been developed.
Choice of materials. One factor in manufacturing, the choice of material, among other things, depends on utility or purpose, durability, and 3, cost of development and manufacture of the product. Utility. Articles may have either a utility purpose or a decorative one, sometimes both. Durability. The choice of durable material is desirable. At the same time, economical manufacturing is also desirable in order to keep costs down.
For example, bolts, nails, and other items of hardware are available in durable and non-durable items.
Cost of development and manufacturing. Also important is the estimated cost of manufacturing the product, which must be done economically. Otherwise, the product will be of lethal use. Processing. In manufacturing, the third and last factor involved is processing, which requires machine and labor.
For example, the manufacture of safety razor blades uses highly automatic machines, several of which may be tended by one person. Other processes, however, may require 2 or 3 or more attendants to a machine.
Trend to automaticity. The tendency in machine designs is to make machines more automatic in their operation so that less labor is required. Advantages of automaticity. It is obvious that the more automatically in an operation, the less labor is required and consequently, the less costly they will be. Layout influences production. Another determining factor in production is layout. There are other factors influencing an ideal arrangement. Some of these factors are the size and shape of the space available, accessibility, convenience, transportation facilities for moving materials, light and power facilities, and others.
Sometimes, these influences can be wholly or partly satisfied or overcome. Sometimes they are insurmountable, especially if to correct them requires the outlay of money that is not available.
Efficiency of labor. The efficiency of labor likewise has a marked effect on price and market. When Mr. Henry Ford in 1940 set a day minimum wage for all workers, he took a step that assured him the peak of the mechanical skill in the country.
To pay an incompetent worker a highly wage does not necessarily increase his efficiency. To pay a lazy worker a high wage may encourage him to lay off and leave after earning a little extra money.
Necessity for continued operation with effective machines and equipment and with efficient employees and workers. The manufacturer should realize that this remaining successful in business depends upon his ability to continue to produce what is needed in the market at a price the customers are willing to pay. Cost of materials and labor affect the price. Equally so idleness. The overhead cost of an expensive machine must be considered.
The manufacturer, therefore, must try to keep his machines and men in operation. This involves careful scheduling of operations, orders, and materials.
Control of production. In the broadest sense, control of production signifies the management of manufacturing. Primarily, it is concerned with the aspects of time, place, and quantity. Control of production uses all the information in dictating what is to be made, from what is to be made, where it is to be made, and how it is to be made. Production control facilitates the flow of work, sees to it that parts are needed when they are needed, and enables the company to meet time schedules. Production control is used as a gauge in tracing waste, loss, and many business failures. It serves as a powerful and profitable mechanism when properly applied. Steps in production control. Production control consists of a well-defined set of procedures that has an objective, the coordination of all the elements of production into a smoothly flowing whole, resulting in the fabrication of products with a minimum of interruption and the earliest possible time and the lowest possible cost. Production control is performed to assist in utilizing designated materials, machines, and men for the proper amount of time at the right time. Production control, as the term is commonly used, is not restricted to time use controlling only. Since production requires materials, either raw or finished parts, production control normally includes fair planning amount, the type and kind of materials required for the manufacturing order release. The manufacturing process, made up of various sequential production operations, is determined in production planning. Routing concerns the establishments of the path which the production will take in its travel through the plant. Scheduling is the assigning of clock or calendar times for carrying out the various operations. Dispatching. The last part of production control emphasizes correcting the deviation, if any. It includes giving work authorization to proceed with specific batches of work at specific times, securing reports on work progress, and granting of authority to move materials from one area of the factory to the other. Without dispatching, production work would not get started when and where it is to commence. Inventory control covers raw materials inventories, goods in process inventories, unfinished stock inventories, and supplies inventories. A close check of insurances is made. Accurate records that give a true picture of the status of items are established. Quality control. The manufacturing end of a business is not only responsible for production, for producing quickly at a reasonably low cost, but is likewise responsible for the quality of the product.
Usually, however, certain tolerances are allowed. Limits within the product may vary one way or the other.
The product engineer takes care of designs and specifications of the products of an enterprise. Quality is maintained through inspection. The inspection department does not create quality but measures the quality of products against the standards set by the company. Careful inspection has a direct effect on cost. In the manufacturing process, the earlier the defects are discovered, the less labor will be subsequently wasted on defective material. Maintenance. Practically every enterprise of any size, hotels, store, school, factory, or utility has its maintenance department. Adequate maintenance and inspection aid controlling in production machines. Machine maintenance consists of periodic check-ups, adjusting alignments, sharpening production tools, lubricating moving machine parts, and examining machines to detect any misuse in its use.
It is far better to keep a machine breakdown from happening than to take care of it after it occurs.
Inspection of a work done with a particular machine is a common machine control technique.
It is effective and perhaps the cardinal test because what's being accomplished by use of the machine is the importance, consideration, and answers whether performance is taking place according to plans. Any necessary corrective measures can thus be ascertained and the proper action taken.